Bismillahirrahmanirrahim. Welcome back to my next video lecture that is about the electronegativity trend. But here I modify the trend of the electronegativity. In the previous video I tell you that electronegativity increases from left to right in a period while it decreases from top to bottom in a group. So here I tell you what are the basics characteristics, what are the basic phenomena that causes the increase of electronegativity when we move from the left to right in a period and cause the decreases in the electronegativity when we move from the top to bottom in a group. Before watching this video I have a request, please subscribe my channel and get the latest video. So let's start off our topics, that is about the phenomena involving the increased electronegativity along the period and the decreased electronegativity from the top to bottom in a group. So first of all, I tell you why, and there is a question in your mind, why electronegativity decreases from top to bottom in a group. The first phenomena and the most common phenomena, that is the nuclear charge, decrease in the nuclear charge. In the previous lecture I tell you that when move from the top to bottom, for example here I consider the example of the halogens family, that is the fluorine, chlorine, bromine and iodine. So when we move from the top to bottom in a group, there is a decrease in the nuclear charge. What are the nuclear charge? Nuclear charge is basically the number of the electron and number of the proton. As we all know that when there is an increase in number of electron, there is also a decrease in the number of proton. So in this phenomena, the shielding effect increases. I discussed the phenomena of the shielding effect in the next video, but here I tell you the short and brief summary about the shielding effect. Shielding effect basically the decrease in the force of attraction between the nucleus and the valence shell electron. Understand? So when there is decrease in the nuclear charge, when move from the top to bottom in the group, the shielding effect decreases. The hold of the nucleus on the valence shell electron start decreases. The valence electron further away from the nucleus. Basically, the shielding effect, the valence electron shield by the nucleus. Understand? Shield by the nucleus. So this shielding is affected. So that's why it is called the shielding effects. So this shielding effect increases due to the increase in the atomic size. Due to increase in atomic size, the nuclear charge decreases. And due to decrease in the nuclear charge, the electronegativity decreases from top to bottom in a group. As we all know that the atomic size increases due to increase the number of the shell. When the number of the shell increases due to decrease in the nuclear charge, so the holding between the nucleus and the electron and the valence electron decreases. So that's why the electronegativity phenomena is decreasing from top to bottom in a group. As the electronegativity ability of an atom to attract the shared pair electron toward itself. So the ability of an atom decreases to attract the shared pair electron toward itself because the electron further away from the nucleus. So that's why the electron went further away from the nucleus, so the electron ability decreases to attract the shared pair electron toward itself. Mean to say the atom ability decreases. So when move from left to right in a period, why electronegativity increases? As we all know, when move from the left to right in a period, from hydrogens to the fluorine, the number of the nuclear charge increases. Nuclear charge is basically the number of the electron and the number of proton. So when the number of electron is increases, the number of the proton also increases. So the shielding effect decreases. Shielding effect means to say the valence electron shielded by the nucleus, inner core electron. So this effect, the effect which decreases the shielding of valence electron toward the nucleus decreases. When this effect decreases, mean to say the electron are attracted toward the nucleus instead of the electron are further away from the nucleus. So due to decrease in the shielding effect, the atomic size decreases. The atomic size decreases because when we move from the left to right in a period, we know that the alkali matter, the one period have one shell of the periodic table and the second period have the two shell at the periodic table. So when you from the left to right period, the number of shell is retains. Every atom retains the number of shell. So in that manner, the atomic size start decreases because there is no increase in number of shell, but the increase in number of nuclear charge. So due to increase in number of nuclear charge, the number of electron proton increases. The atom assemble itself as electron-rich species, so it has a greater ability to attract electron toward itself. For example, when we move from the left to right period, the fluorine have the 3 lone pair. Similarly, the oxygen have 2 lone pair. So that's why the number of electron is increases, the number of lone pairs increases. As a result, the electronegativity start increases along the period. So that's all about my topics. I hope you all understand. If you have any query, any question, you may ask in the comment section. Allah Hafiz.